Okay, are we good? Okay, thank you, Andrei, for the presentation, and thank you, everyone, for attending this event. First of all, at the beginning, maybe the purpose of the presentation won't be very clear. Maybe at the middle won't be very clear, but I assure you at the end, we'll get, we'll get there. Okay, first of all, let's talk a bit about language. Language is something that we take for granted. It's like the air we breathe. It's everywhere. Language is a living system. Language has some rules, okay, like syntax or grammar. The language is symbolic in the same time. We use words, we use symbols, we use gesture in order to communicate. Also, humans are able to specify abstract ideas to language. We are the only being on this earth that can create whole worlds with language. And furthermore, a language is evolving. It's like an organism. And this is a challenge for AI at this moment. Language is evolving. The AI is a bit behind the evolution of the language. And with all of this, we don't know actually what language is. Do we have a clear definition for language? I assure you no, because I did some documentation for this project. Okay. Our brain capacity, it's limited. We have just a few letters, 20 or something, depending on the language. We have some words, 100 words, 1,000 words. But with those words, we can create infinite meanings. Okay? In our lives, we maybe learn 2 languages, 3 languages most. There are certain people that will learn 7 languages, but with only 1 language, we can express everything that we can think of. Okay? Now, knowing that, how easy is to train a large language model, an AI, let's say, general, to know what we are saying. Example. We have a pencil here. Everybody knows that this is a pencil. Is there a logical link between the word pencil and this thing? No, it's not. It's arbitrary. So pencil, for this object, it's an arbitrary word. This means the language is arbitrary. It means that we need a social contract in order to understand each of us that this is a pencil. Behind the pencil, there is an object, and the object itself has meaning. You can write with it. With language, we can also create barriers. There is a theory that says that there are so many languages on Earth because at some point in time, group of people want to keep out other people. How do they do that? Inventing another language that those other people cannot understand. Regarding the social contract, sometimes, and I point here the mainstream media, tend to break this contract. It rewrites the rules. It tries to make us think in the way that they want. They use lots of tactics. One of the tactics is framing. They load words. Maybe you heard at the news bulletins that extreme weather, rain, snowfall, and so on, is not called extreme weather. It's called bad weather. Weather is not good, it's not bad. It's just weather. They are saying it's bad. Yeah, we just take it as it is. And there are lots of other traps that mainstream media wants to apply on us in order to make us think in a certain direction. Knowing all of that, I ask again, how hard is it to learn a machine in order to understand human language? A machine understands logic, understands rules, but our language is not based necessarily on the rules. It's based on the rules when we are writing it in order to be correct. But with words, you can do anything you want. It's not about logic, it's about creation. So machine understands logic, but human language is a creation. It has the freedom, every person has the freedom to create millions of meanings for each chain of words. This is why we arrived at a project. Actually, it was Andrei's idea, and I helped with the creation. We created an app that tries to see the truth in a news article. Okay, and I'll go directly to the app. No, not here, sorry. It has also a name, false floor, because it's good until one point in time. And I'll show you what's the meaning of that. I'll just take an article. It's a very fresh article and paste it there. And you'll see what it can do. Okay, we are analyzing the articles. Behind the scenes, lots of calls to a large language model and other models are being made, and the article is analyzed. And we'll see the results of this article being split apart into very atomic claims, claims that can be verified. Large language models are probabilistic. One thing here is that even the time the result takes to be processed, it's also probabilistic. It depends how much it thinks. Also, it depends where the request is sent, because LLMs are doing some caching behind the scenes. It depends if the first part of the text resembles any other call that was made, and so on. Now the article is split into atomic verifiable claims. It's an article that was, you can see today regarding the World Economic Forum in Davos. And I'll take just one of these claims here. I'll take one very short one and verify. Now, very important thing, when we try to assess how if an article is true or false, if it tries to mislead us, we look at the article as a whole. Well, that is a big problem, because among 90% of true things, there might be a small lie. We need to take that lie from the article and see, and test it, yeah? Because our brain tells us mostly it's true, then it's probably true. But with this app, we can split sentences apart, ideas apart, and test each one of them. You know everything from here, right? All the stuff from here. And now, some other things are going behind the scenes. It's going on the internet. It brings some news. The news is split again into chunks. The chunks is verified against the claim itself. For each claim, we have a number of queries that are generated. We don't see the queries, but they are behind the scenes. And at one point in time, we can see that an atomic claim, this is very important, it's just one fact that we see here, that we try to verify here, we'll get not necessarily a score, but an evaluation from the large language model if it's true or false. Okay. Furthermore, we have a text here that details everything that was searched. I won't go through it. Also, you have all the supporting evidence for this article. And there are a lot of supporting evidence with the links, with the text that it found, yeah, and so on and so on. And at the point, the large language model, looking at the evidence, pro and con against this claim, verifies that if it's true or false. In this article also, I put something that it's quite false. Donald Trump and Donald Duck discuss the situation of classic cartoons. Okay, let's verify this one. It was inserted in the article. You see, it was taken for an article, although it's something that no one will try to search, we'll search it anyway. Okay, it's true and false also for the large language model, I guess, I'm not sure. Also, here we have also, until it finished, we have here a summary generated by the AI, and also we have some other tabs that are important in order to assess also the quality of this article. Yes and no. I tested only for Romanian in English, but of course we can extend it. As long as the large language model knows how to deal with a certain language, it can be extended. Well, this is a tough one. Okay, let's go up. Verdict likely false. Of course, one thing on the interface, it's not shiny. It's just practical. It's like an airplane. When you go in the cockpit of the airplane, you don't see shiny stuff. You see only practical stuff, hard buttons. Okay, this is the app we have here. Okay, so this is how we verified claims for the article, and it is important because we don't need to assess the full extent of the truthiness of our article. We just need to verify certain claims of the article, because that is where people lose their grasp over what is real and what is not real. Okay, as an example, for me, it was a fake news actually, and it said that the Prime Minister here in Romania cut some social security stuff for the children with HIV. And it was taken from a law. Actually, the law was misinterpreted. But for me, as a person, it took half an hour in order to verify that single, very clear information. What are stuff we find here? We have also the knowledge graph. The term knowledge graph was introduced first by Google. And that was it. No one knows anything else about it. In their search in the years 2000 and something. We need to see this article as a connection between entities. And this is another important thing, because this is a summary of the whole article. You don't need to read it. You just look here and you see, for example, at the middle, it was an article about Donald Trump. He's connected to every other entity. Donald Trump met with Donald Duck. That's false. So here in the knowledge graph, it doesn't assess the validity of the claims. It just tries to create a connection between the entities that are present inside my article. And this is, for example, this is a first step for putting together many other articles and doing links between them. And you can see the connection between people, between events, between entities, and so on. This is just the first step. So we can here grow the app, right? The entities are with bubbles here, links are with arrows. Every color here represents another type of entity. Board of Peace and United Nations, the organization. Peoples are with, of course, Donald. People are with blue bubbles, and so on. In my opinion, we as a society work as a knowledge graph, let's say. We exchange information as entities, and this is the way you can also see things that might happen, might be connected over time. Another thing we have here, a linguistic analysis. This tells us about the quality of an article. For example, the overall sentiment is neutral. It's not inflating some event. It's not very sentimental about an event. It's neutral. It just shows the facts, and that's it. Yeah, we also have a bar plot here regarding some other information about it. It's in sensation. It's maybe a little bit. It's objective most of the time. Also, we have some phrases here that tend to mislead sometimes the reader of the articles, like beautiful piece of property. I guess you know what that is. It's Greenland. Okay. Ambitions and so on. Also, we have to depict the subjective sentences that appear in the articles. In order to know what is true or what is false, we have to take subjectivity aside from an article. Oh, it's Gaza. Sorry, it wasn't Greenland. So Trump called Gaza a beautiful piece of property. Yeah. Now, we've seen all of this. I guess you already have questions about how trusty this application is, because we are talking about cybersecurity. This is very important. I'm not talking about the cybersecurity of the site. I'm not a web developer, so I guess it's easy to crack. No problem. But we are talking about security in the context of, do we trust the result that this app delivers us? And the question, and the answer is, it really depends. And let's see, what are the problems with this app? Now we saw the app, now we'll take it to the ground and see what problems it has. And we'll take each step. So the first step of the app is to split the text into chunks, atomic chunks, that are objective and easy to explain. And let's see what problems might occur here. I won't go into details, just take some of them and discuss a bit. Compound complexity. This is the first one. Large language models have problems with very complex questions, long phrases that where entities, sentiments, facts are entangled. They have a problem in depicting and taking them apart and putting in the right order. If the large language model will extract a very big sentence that contains multiple facts in it, it will be very hard to assess if it's true or false, if it's trusty or not. Trivial pursuit. If in this article someone was talking about the weather, for sure the large language model will say on Wednesday it was rainy. We don't need that. We don't need to clutter the interface with stuff like that, and we don't need to send such queries to the large language model just to infer costs. Status redundancy, very important here. Sometimes it tries to check if Donald Trump is president. Maybe sometimes it won't check if a renowned doctor says that if you vaccinate anti-COVID, you'll get Bluetooth connection to your phone. Yeah, sometimes it doesn't check that the person that said that it's real or not. The next step is search query generation. So for each claim, we have a number of 5 queries that are generated in order for that query to go on the search engine and look for results. Okay? When a certain claim has a query generated to it, the query actually tries to confirm what is inside that claim. It doesn't try to find sources that say this is not true. It only tries to confirm the same thing that the claim says. Semantic echo. Let me look. I don't remember what that is. Okay. Semantic echo. It means that inside my claim, we have some very specialized terms. And when you search for specialized terms, it's possible that only 2-3 sites mention about that specialized word, and that specialized word might be not correct, not exact. We need to expand the search query with terms that are very close or near to the claims we have, not search for the exact phrases. Temporal stagnation, another problem, because if I'm trying to verify facts from 2012 and those facts changed over time, it will go for 2012. It will remain there with the search. Search and retrieval, this is the part where you go on the search engine. Circular reporting, it means that we have a few sources that cite the same news article, true or false. Those are the first in the search engine, it will pick those, but every one of them shows the same source of the article. SEO game slope. Maybe you've seen that false articles are well optimized for the search engine. They appear on the top. If you don't go with the search at least over 10 results, you might get the optimized one. Fragmented context. The truth itself cannot be found in one place. You need to search the whole article. Maybe the truth is split onto chunks in the same article. You need to put all of that together in order to assess the validity of that thing. Very hard for the large language models. What else? We are at the part and embedding matching. So after the search is made on the search engine, we take the articles, we split them apart, and we search for the nearest chunks that are nearest to our search query. In terms of distance. Distance is a complex word here. Negation blindness. When you try to compare two sentences, if they are apart in the sense of meanings, Trump is president and Trump is not president, it's very close. So you might get a negation there. You will not find the thing you are searching for. Majority noise. If you have lots of articles that say one thing and one that says different, that says different might be the true one. But the chunks, only the false chunks will get together with the search query and go to the decision. And at the end, we find the large language model. So after we bring all those evidence together, we let the large language model judge if a claim was true or false. We have some other problems here. One of that is fluence bias. Articles that are not valid tend to be right very well because trust comes from an article that is very well written, that has a structure, that it's easy to read, right? Sometimes truth, it contains facts that are like data, like not well written, and so on. But the large language model will favor the article that it's very well written. Middle ground fallacy. It means that if you have 6 sources that say something is valid and 5 sources that say something is not valid, most probably the large language model will say it's good. Trust this one. Source hierarchy blindness. It depends very much on the source of the article. For example, a tweet or a Facebook post shouldn't weight as much as an article over a news site. Of course, depending on the site. Now, at the end, we have how many steps? Okay, we have 5 steps. Let's say in every step here works works 90% of the time. 90% here, 90% here, 90% here. At the end, you'll have a program that works 50% of the time. So you just toss a coin and see if the program will do its job or not. It's very hard, and I tell you this from experience, it's very hard to assess if a large language model, it's good to automate some work. In this case here, when we are talking about news articles that expresses most of human creativity, it's very hard to do a test. You test the first step and so on, and at the end, you'll see that, as we calculated here, 50% of the time is good. When you deal automations regarding very clear tasks like reading some tests and extracting specific words, creating a schema, and so on, that is good. You can use the large language model. But in this case, when human creativity intervenes, it's very hard to create a system that is trustworthy. So my take here at the end is that use it. You can use an app like this, but use it knowing the risks that are behind it. Thank you.